How do we partition a directed line segment? And what does that even mean? So here's the example that we'll be doing in this video. Here we have a point A, and here we have a point B. And we need to find a point P, so a third point, where the ratio of AP to PB is 3 to 2. So we're actually not going to have to graph anything to solve this problem, but I feel like the only way to understand what we're actually doing is for me to just sketch a little graph. So here's a really terrible sketched graph right here. And let's say that we need to plot point A and point B. So let's say that point A is right here, and let's say that point B is like right here. And let's go ahead and draw a line between point A and point B. So partitioning the line segment basically just means that we need to find a third point that we're calling P, and we need to put it somewhere on this line. And the goal is to find the point here, like for example, let's say the point went right here, so that the ratio of AP to PB is 3 to 2. So basically this portion of the line up until P would be 3 long, and this portion of the line here would be 2 long. So A is like 1.5 times longer than B. So in other words, if we were to cut up this line into 5 slices, then A to P would take up 3 slices, and then P to B would take up 2 slices. So the first step of doing this is going to be to find the slope of the line from A to B. And to do this, we're going to need the slope formula. So remember that slope is equal to rise over run. And that's easier to tell when we have a graph because we can see it rising and running. But in this case, we just have points. So we're going to use the other version of the slope formula, which is y2 minus y1 over x2 minus x1. If this doesn't seem familiar to you, I do have a video about finding slope. The link will be in the description. So we're going to replace each of these letters with what we know about these 2 points. So y2 is the y of the second point. So here's the second point. And remember that x comes first and then y. So y is going to be the second number, which is 7. So I'm going to replace y2 with the number 7. Then we have minus y1, and y1 is the y of the first point. So here's the first point, and the y in this case is 3. Next we have x2, which is the x of the second point. So b is our second point, and the x is the first number, which is 5. And then we have minus x1, which is the x of the first point. So here's the first point, and the x is 2. So let's go ahead and simplify this down. 7 minus 3 is 4, and 5 minus 2 is 3. So our slope is going to be 4 over 3. Now, even though we just found the slope, the fact that the slope is 4 over 3 actually doesn't really matter. All that matters is that our rise is 4, and our run is 3. So what we're going to do is we're going to take our point A now. Point A is 2, 3. And what we want to do is we want to look at how many slices we're supposed to put between A and P. So remember that I said that we were splitting our line up into 5 slices. And the way that I know that is because 3 plus 2 is 5. A is supposed to get 3 slices and B is supposed to get 2 slices. So because A is supposed to be getting 3 out of 5 slices, that means that we need to take 3/5 of the rise and 3/5 of the run and add them to A. So first let's talk about our rise. Our rise is 4, but we want to only add 3/5 of the rise to A, to point A. So we're going to multiply 4 times 3/5. But remember that when you're multiplying a fraction by a number, that number is just over 1. And we need to multiply the tops and the bottoms of the fractions. So 4 times 3 is 12, and 1 times 5 is 5. So our rise was 4, and 3/5 of that is 12 over 5. But for this, it might actually be easier to just do this in decimals. So if you want, you can put in 12 divided by 5 into your calculator, and you should get 2.4. And I just realized that my head is slightly blocking this point, so let's go ahead and move it. So to find our new point P, we're first going to find the y by adding 2.4 to 3, which is our original y value. So 3 plus 2.4 is 5.4. So the y of point P is going to be 5.4. So now let's go ahead and do the same thing for x. But remember that for x, we're not dealing with the rise, we're dealing with the run. The run in this case is equal to 3. But we need to find 3/5 of 3 and then add that to x, which is 2. So to find 3/5 of 3, we're going to take 3 and multiply it by 3/5. But remember that when you multiply a fraction by a number, that number is just over 1. So 3 times 3 is 9, and 1 times 5 is 5. And if you do 9 divided by 5 in your calculator, you should get 1.8. So we need to add 1.8 to the x value of a to end up with the x value for p. So we started with 2. We're adding 3/5 of our run, which is 1.8. And 2 plus 1.8 is 3.8. So we found the x value for p and we found the y value for p, which means that this is our final answer. This is the point that's going to split up our line into 5 slices and give a to p 3 slices and p to b 2 slices. So now you know how to partition a line segment with 2 points coming up with a third point. But this is actually pretty similar to another topic that we've talked about, which is weighted average points. So that's going to be when you have a point in the middle, but one of the points has more weight. It's pulling on it more than the other point. If you want to learn how to do that, it's pretty similar to this. Then you can watch this video right here. And as always, if you have any questions about this video, go ahead and leave it in the comments and I'll be sure to answer your question. Thanks for watching.